you produce the drawings?
Hmm.
Like the drawing that me show you about with the youth SBA. How else would you do a drawing like that?
Courtney Soto.
No, it's not. You can do it on paper, but then life would be much harder because if you make a mistake, you have to start over. You can't trim on paper, daddy. You can't move it around. You can't send a copy to sir, make sir edit it a little bit for you and fix it up. No, sir. And if it's dirty, you know, sir, you don't want it, so sir goes, so you have to do it again. You know, like easy life.
Yes, sir.
All right, sir.
I'm not flying that.
Yes, you're not flying.
Yeah.
Yes, man, not work, no work at all, not easy. I just cycle. You're gonna learn. You just start now. So by the time you start doing it, you realize that it's not as hard as you thought. So the first one we're going to do, and I'm going to demonstrate, is the completion of the orthographic projection. With a first or third angle, you get to choose of the camera, right? Now, you have already completed the isometric drawing for this camera, and what you would do next. Let me tell you exactly how I do it, which is I think is the best way, right? Because when I couldn't learn this, I had to go and seek the knowledge for myself. Because sometimes the way how a teacher represents information or presents the information is not the best way for you to learn. So what I'd suggest is also, on top of me giving you the information, you should also go out there and search for information for yourself. Because when you learn it, then, as I always say, what you learn, you shall remember. So now we're going to complete the article review for this camera. The first step and the first thing that I would like you to do is to sketch. Before you start drawing anything, you always have to provide a sketch solution. We're not at that topic as yet, but there's a topic in technical drawing called technical sketching. Now, sketching is basically doing a freehand drawing of the solution that you will do in AutoCAD, but it gives you a basis to work from. Because imagine if you are meeting with a client and they want to produce something for them, like build something, it would be nice for you to be able to sketch out a solution for them, showing them what it would look like first before you actually go ahead and do a drawing, and then wait 2 weeks, 4 weeks for you to actually finish the drawing. No, they want to see something right away. If you say, "This is what I'm thinking. Take a look at this." So the first thing you will do is create a sketch solution. What? So I am using third angle projection, right? So what would this look like in third angle projection? I'm gonna take my time and sketch it out on paper, and this is what a sketch that I came up with look like, right? So I created my sketch solution based on the isometric drawing I was given. Notice me never use no measurement, no ruler. I just basically looked at the picture and envisioned what the plan looked like if I look on it from top, looking down. What would the plan look like? Boom, me draw that. Then I project my line them down and try to keep it in order in line with the plan, the front. I'm say the front have a little circular feature on it, yes. And if I'm looking directly at the front, I won't see that it is has a length or a thickness going back. The camera has some three buttons on the top. It also has a line going across. I draw that, and they have the end elevation beside the front. And notice I labeled my views: plan, front elevation, end elevation. This is how you would label your views, not only in your sketches but also in your actual technical drawing or drawing solution. Notice I have my angle of projection symbol. Now, with the symbol, I don't usually have to write this. However, I usually just write it on it for not my sake, but for persons reading my drawing to know what angle of projection I'm using if they're not as knowledgeable. So the third angle projection symbol is there, the plan is there, the front elevation is there, and the end elevation is there. So we see we have all the components there. So from this now, what I'll do is transfer all of this into CAD to produce the actual drawing. So everybody wants to see me demonstrate. I'm going to demonstrate. You want me to see me demonstrate, or you want to do it on your own? What do you want?
Demonstrate, sir.
Demonstrate. All right. All right. I'm going to demonstrate. So here is how I would produce this in AutoCAD. So first, let me open AutoCAD. Open a window. AutoCAD. Share. All right, you see my screen? Everybody see the screen?
Yes, sir.
Okay, good, good. All right, so you can see now, I have my drawing of the isometric camera there. I also had the drawing that I did recently here. And now I also imported my sketch solution or copy and paste my sketch solution into AutoCAD. Now to begin drawing, I need to know what the measurements are. So how you start your orthographic drawing is basically by starting with your X and Y axis. Now my isometric grid is on, so I turn that off first. Notice I'm using the same drawing, so I have my layers already set up. I don't expect you to create a new drawing every time you're doing a drawing. If the AutoCAD drawing space is too big for you to do that, you can draw a limited amount of things without changing your setup and everything. So when you set up one sheet, you just keep drawing everything there. Notice I call mine fourth form. So therefore, every time I'm having your class, this is the drawing I come to. And I have everything in here. Now, this is an example of an orthographic drawing, but it's more complicated. These are orthographic drawings, but I'm going to show you how I achieve these, right? Now, you start by setting up your screen or your drawing space by turning off isodraft. Ensure that ortho is on because you're doing orthographic drawing. So isodraft for isometric drawing, ortho for orthographic drawing. And ortho basically it keeps your line straight, vertically and horizontally. Also ensure that object snap is on and all the things that you will need, midpoint, endpoint, center point, and all your nodes are connected. Now that is done, what I'll do now is start drawing. I'll start drawing with construction lines. So notice we're on construction lines here. First things first, the axis. Boom, boom. Then because I'm using third angle projection, I'll have my 45 degrees from this center here, up here. To get 45 degrees, I'll have to disengage my ortho and turn on polar tracking 45 degrees, or even keep it on 15. So every 15. So turn on polar tracking and see how we get our 45 degrees here. Enter, right here, 45 degrees.
Sir, so that line can be any length.
What line? This line? Yes.
Sir. The 45
Yes.
degree.
As long as it is bigger than the object that you'll be drawing. So 45, let me select 45 here so I can ensure that it's 45 degrees. All right, so that is 45 degrees. Boom. All right, so now I have the axis plus the 45-degree line, and this is what I use from, all of this is what I'll use for my projection. So now I don't want to draw on my axis, so I'll offset 10 millimeters, or let me use 20, so I'll offset 20 millimeters. Offset is that, and we type in 20, enter. So you can either click offset or type in offset. OFF offset and type 20, enter. Click on the line that you want to offset and the direction you want it to go. Click on the line and the direction. Click on the line, the direction, line, the direction. So I change my axis colors now, so I can differentiate them from my offsetted lines. Change these to object lines. Or projection, no, object lines. Change these to object lines. Good. Now I can start drawing on my construction lines. So the first part of the camera I want to know, the front is here, right? And I assess the information, maximum length by maximum height or maximum width. So because I'm looking towards the front here, all I'll be able to see is this, everything that is here. So all I'll need is length or width, whatever you recognize this as. So this width here by height. So the camera is 100 wide by 50 plus 10, which is 60 high, right? So I do that. Start drawing. It was 60, right? 50 plus 10, 60, right? No, 60. More than 60 because up here, this 10 too. So it's 10, 10, which is 20, plus 50. So that is 70. So I go down 70, enter by 100. So 70 by 100, 100, enter, then go back up 70. And that is the maximum length by maximum width for the camera. Now I start breaking it up into pieces. So the first thing I need to do is find the center for the circle, which is basically line, selecting the center point, midpoint, drawing a line up. Circle is found between the 50 and the 60 points. So I find where 60 is, or offset 10. So I'd find the center of 60, which should be 60, go up 60, enter, draw this line, which gives me the top of the camera. Up here would be the bases for the button. Now, what I will do now is find the center point for here. Center point. And I can use this center now to draw my circle. So click circle, find the midpoint, and the circle, the radius is 50. Radius is 50 for the circle. So I'll do that. 50, enter. No, diameter is 50. So the diameter is 50, the radius is 25. So 25.
They always messed up.
Yeah, always. 25. So that's there. So the radius is 25. So basically I have the front of the camera almost there already. Now, this line would basically need to be drawn now. This one here, this line here, which is 10 down from the 60, right? So I need to step off 10 down to get this line here. So offset 10. So click offset, type 10, enter. Step off, boom. Then I'll trim this out. TR, enter, trim, trim, and I can delete this line now. So we have almost have the front of the camera now. So what we're doing now is basically forming these buttons on the top. So we'd have to go back here, see the measurement. So the height of this one here is 5. The height of this one is 10. The height of this one is 5. So I'll have to divide the 10 that I currently have into 5 and 5. So I offset 5, 5, enter, boom, right. Then decide where this is. So we know that this one is 15 from the center of this one here. It is 15 to the center. So we'll offset 15 and find the center. And from here, it is 15 just the same to the end point, not the center this time. There's 15. No, it's actually 15 to the center because the center is the same as the end. So it's 15 to the center of this one, 15 to the center of this one. So from center to center is 15. So we'll do that. So 15 this way. Turn on ortho. 15, enter. We have our center line right there. And then same thing over here, 15, enter. 15, enter. Boom. Then the thickness now, the width of it is, of the circle is 20 diameter. So we offset 10 on both sides. So 20. So a circle in orthographic projection is a square. So offset 10 and 10 on both sides. So offset 10, 10 here, and 10 there. Good. And then I can trim. TR, enter, trim, and delete this one. And this one here is 15, and it seems as if it is 15, so 10 there, 5 on each side. So 5, 5, 5 all around. So offset 5, enter, 5 and 5. You can stretch the lines. Instead of trimming, sometimes you can just stretch. So delete. And now I can get this one out of the way, trim this one, TR, enter, boom. So I have both my buttons now. So the next thing I'll need is basically Next thing I'll need is the middle button or the flash on the camera, which is this piece here. So this incline here, when you're looking at it from the front way, all you will see is just a rectangle, just the same, because you cannot tell that something is inclined by looking at it directly in front of it. Just like you cannot tell a circle is circle by looking directly in front of it, you won't be able to tell that the inclined plane is inclined. So you draw it as a rectangle, given the same height. So we represent it as 10 from the center, and this says that this is 35 from this side, 10 up, and then 30 that way. So we'll measure 35 from here. The first thing to do is 35. So 35, enter, then go up 10, enter, then come across 30, enter, then come down. And that is you for the flash, right? So now when you finish the front, like how we finish the front here, now what I can do is change my lines to object line. So changing it to object line will make it more obvious. So I change it to object line. And the reason why I change it is if I turn down line weight now, I will see that it is existing and the construction line is thin just the same, right? So that is the front of my camera. When you completed a view, all you do now is basically label it. So I label the front elevation. Let me get some words from somewhere else. Copy. So instead of forming new letters, I just copy the old ones and edit it. This is the front elevation. All caps all the time. Front elevation. Boom. Then we go project our lines now. So I go switch from construction lines to projection lines. Projection lines. So I'm going to project my lines to get the plan. So I project my lines from here upwards. And my projection lines have a thinner and lighter look because I turned the transparency down. Notice I'm projecting from each point. You don't have to do this if you find it confusing. You can use one point at a time. Let me not use so many because I don't want to confuse. Right, so I'll use just the width first and then arrive at my width. So this projection line here and this one gives me my width so far. And what is the height? The height of the plan or the width of the top would be, so I have this length already because I drew the front, which is 100. So all I need now is this, which is 15 plus 15, and that gives you 30. So we know the height here of the plan would be 30. So I draw a line, 30, enter, come across, boom, 100. And this is the rectangle that we'll draw our camera in between. So now all we need to do is project this one upwards. Somebody tell me, what am I doing wrong just now? What have I done wrong just now?
Putting the plan on the wrong side.
Putting the plan on the what? No, that's not what I did wrong.
Oh.
Look at the front. The plan is above the front because it's third angle, so that is correct. But what am I doing wrong? Look at the front. What am I doing wrong? I didn't take into consideration the circle here, the lens that is projected out. See, I just have 30. But in reality, it is not 30 wide. It is 30 plus 20, which is 50. Because you have this, the rectangle, plus you have the circular piece that projects out, right? So the height should be actually be 50 and not 30. See that? So 50, enter, boom. Then I can take back the 30 from it now. So offset, 30, enter. So this is the base and this is the circle, the third 20. So 20 from here and 30 here. So this 20 first to give me the camera lens. So I project my lines up to here, and this gives me the camera lens right there. And I change it to object line so you can see it more obviously. So the camera lens is gone. So I delete this projection line. I can leave it or delete it, depending on what you want to do. Because it's kind of confusing if you have too many of them. So I'm going to leave it. So from this one now, from here and here, I project this line up. And this line here also up. And find where exactly the center is so I can find the thickness of this. So the circle is 20, so it's 10 and 10 on both sides from the center. So I find the center line. Center. And then from this line, I can offset 10 on that side and 10 on that side. Offset 10, enter. In that way, in that way. And this will form our circle. No, it's a square may I form. It's not a circle. Right. So this is the center point there. And then I'll come in 15 from the edge. 15 to the center, 15, enter. And this is the center point for the circle right here. So I'll draw the circle now. Circle. And the radius is 20, so the diameter, no, the diameter is 20, so the radius is 10. Enter. And that is the circle, right? So you see that it fits perfectly within this. So that's what your projection line helps you to do. And if I have wanted the center, I could have done this too, from center to here. See, same center. All right, so basically that is that. So what I need now is this one. So I project my lines up just the same, up to the top. Project my line up to the top. And then look at the front again and can see that this has a 45 degrees there and this is there. So basically 45 degree would basically come up and measure because it's a slope, right? And you can't tell. Remember what we did with the nut, with the hexagonal nut? You had to draw it flat before you can tell what measurement this is. So an incline isometric will not have a measurement. So you have to draw it flat first to tell what the measurement is. So basically, I can get the measurement from here because I drew it. So I know that from here to here, where it would be. Turn that off. And put that on. Boom. So the measurement from here to here is measurement aligned. Measurement from here to here is 5. Right? So that's 5 there. So I'll offset 5, enter. Need to draw it first. Draw a line there. Offset 5. Right, and then connect it. So rectangle, boom, boom. And then we'll go ahead to this one. So boom, boom, and change this to object line, boom. And then for the small one now, project your line upwards. Project your line upwards. And this itself is 5 on both sides. So we'll offset 5 here and 5 there. So let me minimize this line. Boom, offset 5. Enter, 5 there, 5 there. And then I'll trim it out. Trim all the extras I don't need. So boom, boom. All right, so I can delete these projection lines now because I don't need them anymore. Connect these rectangle, connect here to here, and then put all this in object line. Object line. So now I have 2 views. I have the plan and the elevation, front elevation. So that's the plan and the front elevation. Oh, I
Sorry,
deleted the camera
download the
lens.
Yeah.
The lens? Yeah, because I deleted the lens accidentally. So the lens is here. I shouldn't have deleted that. We are enter. So the lens is here. Lens. Lens. All right. And then change everything to object lines. Good. And then that's it. The lens is there now. So this is the plan of the camera. This is the front. So how to get the end now? So basically what I'll do is label the plan. And even though you see me going through these steps, and it's just because I'm trying to show you, that's why I'm taking so long to do it. Now, when you are doing it, you don't have to go through all the steps that I just did. All you need to do is ensure that your views line up. That's all. The most important thing, your views correspond with each other. So plan. And please don't write plan elevation. There is no such thing as a plan elevation, because a plan have length by width, not height. So plan, please, no plan elevation. All right, now to get the end elevation, all I need to do is project my lines from over here to here, and from here to here, then down. And this would give automatically gives me the end. So when you come up with your front and your plan, the end is automatic. Just project your lines. So that's what I'm going to do now. Project lines from here, here, and then down. This is there. And from here to here, from here to here. Here, turn off line, wait. So from here down, from here down. So this automatically gives me the width. And now for this one, so from the top here, and from here to here, and from the base to here. And that's it. The camera is there already. Are you seeing the camera? You seeing it? You see it? I can't see it yet. All right. If you can't see it, let me show you. So here is the.
Yes, sir, we can see.
Okay, so here is the side of the body, and here is the plan. So what you do is project from the circle, top of the circle, to here, and from the base of the circle to here. And the rectangle, boom, form that. And then change that to object line. So that is the lens already there. Object line. And then this is the body of the camera. So rectangle, boom, change that to object line. Boom. And then now you have the lens, you have the side. What you need now are these, right? And you need this line too. So boom, this line over to here. Boom. So boom. And then we can change this to object line. Then we need the buttons on top now. So you project your lines from these points over and from these coming down. And these will automatically give you what the measurement of these buttons are. And for the circle now, same thing. Yeah, boom. Come down here. From each point, you come down, break it down. From this point, project down. All right. So now that you project it down, you can basically draw in these pieces just by drawing the lines across. So this line for this one will give you this one. Boom. You come across this way, and that's it. See it. So you can see the small button here. This button is here. If you look back, it traces right back to it. See that? That's why I use the 45 degrees. So it traces right back to it. Boom, go there and then down, and it gives you the small button, so you know exactly what you're doing. For this here, you trace all the way back, you see where it's coming from. You always know where it's coming from based on how you can trace it. So this is the small button here. You can turn that to object line. All right, good. Now behind the small button you have this one. So if you're looking in this direction, from here to here, looking in that direction, this small button, you have this one after it, and then this circle behind it. Now this one is hiding the circle, so the circle would have to be in hidden lines. So we draw this one first, and this one is basically from here, coming all the way over to up to 45 to the 45 degrees. So I turn on this 45, I get the 45, come to there, 45, and then I go across and come down. And that is the top part of the camera. Object line. Boom. And then now for the circle. The circle has these lines coming across, right? Boom, boom. So the circle is 5 high, and the circle comes from here. So the circle would be in hidden lines because it's hiding behind these. So the circle is 5 high, and it is between here and here, right? So the circle stops at this edge of this one right here and comes down. So all of the circle is in hidden line. So basically I'll draw a rectangular box and make it hidden. Change it to hidden line. Hidden. Right. Now I have to delete all my projection lines to make the drawing clean and clear. So let me just keep a copy of this and then remove this, put the side as a copy. Put this here and delete my projection lines. In manual drawing, you would keep your projection lines because you can't erase them because you need to show you're working. But in AutoCAD, you don't need to keep projection lines as long as your drawings are in line with each other and are in sequence. So basically, this is hidden line. Let me change the line scale on it. Properties. Find line scale here, 1. So it is broken line. We can see that it's broken line here, but because this one you can't really see the broken, the spaces between it. So I change it to like 10. Enter. And now you can see the broken pieces. All right, so this button is there, that button is there, and that one is there. All right, so do my transition lines, and this is the end elevation of the camera now. Copy, put it here, and rename it end elevation. And we are just in time. Class is just about done now, and that's it. That's how you draw your camera in orthographic projection. Now, what I do is now get the same border, and I scale this down. SC, enter, R, enter. So R is reference, a scale reference, so it allows you to. So the camera, boom, and then put the orthographic projection of the camera now, so I can delete the orthographic lines because I've worked and formed everything, so it's good now. So I move it, move, put it in there. Orthographic view. Then I use third angle projection, so I just get my projection symbols there. So my third angle projection symbol, and I'll add it to it. This is kind of big, so I'll scale it down a bit smaller. SC, enter, R. And then click reference for R, and then you can click 2 points and drag it smaller. And move it into a small corner. Right, so this is third angle projection. So I have my camera in 3 dimensions, and I also have my orthographic projection. So this is a isometric camera. And this is the orthographic projection of the camera. So this is orthographic projection. Orthographic projection of camera. Right, so I can position this a lot better by moving this over here and then moving this into the space. And then I'll put this picture here, copy, and paste it somewhere close into it. Move it into the sheet. So you always move all these views together because you don't want them to be, you want them to be remain in the same order that you created them. And then I can put my sketch in there as well. So copy. So everything is on one sheet so you can understand the process that I took to get to where I get to this solution that I currently have. Boom. So I have both my sketches and I also have my drawings. There you go. So if I should plot this, here's what it would look like. It would look just like this. Print. Most people, you should pay attention right now. So you plot drawing to PDF. Select A3, which is the landscape part, top one. Ensure that it says landscape. So when you're plotting, it looks proper. Fit to paper, ensure that this is done. Ensure that center plot is NEH. So center plot, fit to paper. Use A3, the top one. So A3, not that one, because this one is portrait. You want landscape sheet. So you choose the top one, which is A3, the top one. Landscape. Ensure that here is that is that. Monochrome CBT. If you have any of these other ones, you're going to have color in the drawing. So if I use any of these, I'm going to get some color and I preview it. Hold on, let me draw a window around it first. So window around the exact page perfectly and preview. Notice it's in color. I can't see anything. I notice that your drawing has this effect sometimes and I can't see anything in the title block. You need to ensure that your drawing is in monochrome CTB, which is one color, mono one. Preview, which is black, and you see everything is here. Now this is what I want you to send to me for your next assignment. The orthographic view of the
Sir,
camera.
put a tutorial video when you post to work, sir. Again.
Put a what?
Put a, like for the camera they put a video beside
Okay.
it. Yeah.
Alright. No problem. Alright, here you go. We have come to the end of the class. You can go ahead and do some more extra research. You can also not just do extra research, but you can also you can also read the slides, watch the videos, and then I'll post the tutorial video for this one, or even this class recording. I'll post the class recording so you can access it and see what and complete this one. All right.
There says fit to paper, make it go in the middle properly.
Yeah, fit to page. Make it in a paper. So you have to engage fit center the plot and fit to paper, and it fit perfectly in the paper. So these two, yeah, ensure you engage these two and monochrome CTV, and then you'll be all right. Everybody good?
Yes, sir.
All right, good. Any questions before we go? Any questions or concerns before we go?
Yes, sir.
Huh?
No, sir. No, sir.
No, no? All right.
No, sir.
All right, good. Take a little break and then come back to it later because this is a lot to absorb one time. So just go and go take a little break and then when you finish, you can come back and attack it. Or one next day. Okay?
Yes, sir.
Good evening, gentlemen.